Round off our notes of the geometry of solids with just a few more solids here. Beginning with the sphere, and I'm going to give you kind of a technical definition of a sphere, but you guys probably have a good idea in your head what a definition of a sphere is, or what a sphere would be, even if you don't have the exact definition. A sphere's definition is a set of all points a given distance from another point. Okay, so in a sphere like this golf ball over here, you've got the center, all right, inside of the golf ball, the exact center. And then you have a radius that goes out to the edge, right here. And the set of all points that are on the outside of this golf ball will all have the same distance to the center. So we've got the radius here, but there's literally an infinite amount of these radii that we can draw in here from the center. And so the set of all of those points, a given distance, a given radius from the center, will eventually make a sphere. So a sphere, you can just imagine a ball or something circular like a globe, three-dimensional circular shape. Then we have something called a hemisphere. So a hemisphere is half of a sphere. Okay, the prefix hemi means half. So a half of a sphere and a hemisphere will have a circular base. So if you can imagine, just try to draw this in perspective here, but that is a circle, and then half of the sphere. It's kind of like a dome, really. That's the hemisphere. So if you take the Earth at the equator and chop it right down, right through the equator, right through the center, you would have the hemispheres. And in fact, that's exactly what we have when we refer to the Earth. We refer to the northern hemisphere, which is above the equator, and the southern hemisphere, which is south of the equator. And so that is a hemisphere. Now, a great circle is another term. We don't use this term as often, but a great circle is a circle that encloses the base of a hemisphere. So the great circle would be something like this right here. And so if you can imagine, I'm going to just do a little erasing with our golf ball over here and redraw in. So think of this right here as kind of the hemisphere, or the equator, I should say, of our golf ball. And maybe we can even draw that a little bit better. Let's see, front, and then maybe I'll make the back dotted to give that perspective right there. So that's like the equator of our golf ball. And that would actually be a great circle, because on one side of the equator, you've got the hemisphere, the northern hemisphere, and then on the other side of the equator, you've got the southern hemisphere. And that right there, the red part would be the great circle. All right, moving on to a cylinder. So a cylinder is a solid with two bases that are circles and a curved lateral side connecting the bases. So a solid with two bases that are circles, so two circular bases, and a curved lateral side connecting the bases. All right, so we see a cylinder down here below. And so we've got the bases, which On the shape right here, you can see we've got this light green base, and we have the same thing on the bottoms. There's actually two bases, the other one's down here. So you've got these two bases right here. And then the curved side, which is the blue right there. So the blue would be the lateral side, and it's like the soup can label. The blue side's kind of like the soup can label. We talked about using that for surface area of a cylinder, so hopefully that is familiar to you. Now, a right cylinder is a cylinder whose axis is perpendicular to its bases. So a cylinder whose axis is perpendicular to the bases. Now, when I say axis, I mean if you put a point on the two bases of your cylinder, so a point at the center, I should say, of the two bases, and draw a line straight down through that, that is called the axis of our cylinder. And that axis, if it's a right cylinder, is going to be perpendicular to the base. So that axis that goes right through the center of each of those circles will be perpendicular to the base. Now, if it's an oblique cylinder, we talked about how oblique is kind of tilted off to the side, so maybe you can sketch an oblique cylinder. So let me just see if I can kind of sketch an oblique cylinder. So I'm not the best artist in the world, I'm going to do my best, but if you make two kind of circles in perspective here and draw lines between the bases, that would be an oblique cylinder. And so if you look at the axis here, so if we draw a center point and then draw the axis, so there is our axis again of that cylinder, notice that that is not going to be perpendicular to the base. So if we made a little angle here, that would not be a right angle, that would be, well, on one side it would be an acute angle, on the other side it would be an obtuse angle of that axis. So that would be an oblique cylinder. All right, moving on to a cone. Cone is pictured down at the bottom of the page. Okay, a cone is a solid with one base. That is a circle. Maybe the better way of condensing those words would say one circular base. So one base that is a circle. And a curved lateral face that meets at one point called a vertex. Okay, so down here we've got our cone. Here's our vertex right at the top here. And we've got a circle for the base down here. And you guys are familiar with cones. We talked about their surface area a couple of units ago. And a right cone, just like before, will have an axis that is perpendicular to the base. So is a cone whose axis is perpendicular to the base. And an oblique cone would be, just like we talked about before, would be a cone whose axis is not perpendicular to the base. So here's the axis. If you draw a line straight down here, and we'll do it in green, straight down from the center to the base. So there is the axis of our cylinder there. And notice that this is a right angle right here. The axis is perpendicular to the base. And if you had a cone, again, we sketched over on the side here, let's say this is an oblique cone. Oh, that is really bad perspective of a circle here. So let me see if I can try that just one more time. And if I can't make it, then I won't do it anymore. But something like this, and the vertex of the cone is kind of off on the side here, that would be an oblique cone. And notice that if we draw the axis on that one, so from the vertex to the center of the base, then that axis right there is not going to be perpendicular to the base. So that would be an oblique cone. All right, so that's a whole lot of vocabulary for this first section, and that's really what your homework is going to be on, a bunch of vocabulary. So we'll see how that goes. I think it'll go fine. Some of these terms should be familiar to you. We've used them throughout our year in geometry at times, but now we are officially defining them in the context of a three-dimensional solid. So that's what's different here, is we're talking about 3D shapes for really the first time in the year. Almost all the rest of the year has involved two-dimensional flat shapes outside of a little bit of work with our surface area back in Chapter 8.